I'm going to bring in Patricia here to do the changeover for your talk. Thank you, Dinakar. Thank you, Kusuma, for that excellent talk on how to scale your containers. And Patricia is going to take a little bit of a different look at technology around that. And I always say to myself, Rory, don't ever offend anyone who has a talk with the word hack in the title, because they know a lot about you already. So I don't want to be hacked, Patricia. So I'm going to say right up now, XSS is one of the main concerns that I have always when I'm deploying a website. I use CodeQL to do that. So Patricia, I'm going to hand it over to you. Thank you, Dinakar. Thank you, Kusuma. And look forward to your talk.
Hello, everyone. Great to be here. And my name is Patricia Węgrzynowicz, and today I'm going to tell you about XSS Injection and how to use it to, for example, do phishing attacks or hijack victims' sessions. Briefly about myself, I've been doing professional software development for over 20 years. Most importantly, I founded Yon Labs. That's a startup where I work on automated detection and refactoring of software defects, mostly security vulnerabilities and performance anti-patterns. So basically, security is my daily job. What am I gonna show you today? Basically, after brief introduction to XSS, I will focus on 3 demos. And I want to show you XSS in practice, just for you to feel it. So let me start with explaining what cross-site scripting actually is. Actually, cross-site scripting is a kind of injection attack. It happens basically when malicious scripts are injected into otherwise benign and trusted website. Usually it means injecting JavaScript or some HTML code. Why does it happen? Because usually in our web application, we don't have proper input validation or output escaping. Basically, XSS made it to top 10 OWASP security vulnerability risks. And it's been on the list for many, many years. OWASP stands for Open Web Application Security Project. That's a non-for-profit organization which aims at increasing awareness of security among developers. And every couple of years, they publish top 10 security vulnerability list, and most recently it's been published in 2021. And as you see on 2021 list, we have a more general class of attacks like injection, and it covers XSS. We have like a combination on a more general injection and more specific XSS from 2017 list here. What XSS and how dangerous XSS is according to OWASP. Basically, XSS is very easy to exploit. It's a very popular but easy to detect security vulnerability. And what is the impact of XSS? It depends. Technical impact itself is like medium 1, but combined with other security weaknesses in your application, it might be very dangerous from the business point of view. I would like to keep this introduction to XSS very brief and simple, because the fun part of today's talk is to how can we exploit XSS vulnerabilities and how dangerous they are in practice. So a couple of slides about different types of XSS, just for you to have a basic understanding. So basically, there are different classifications of XSS vulnerabilities. The most popular one is to distinguish three classes of XSS attacks or XSS vulnerabilities, rather. Stored XSS, reflected XSS, and DOM-based XSS. Reflected XSS happens when injected script basically is in URL, and then a web server reflects it off to the response. So it's delivered to a victim via link, via other web page, and links in those web pages, and that's kind of attacks. In case of stored XSS, this one is more dangerous because basically malicious script is permanently stored on a target server, like in a database, for example. Usually, it refers to some sort of visitor logs, forums, comment sections, etc. So a victim is prone to an attack via just regularly browsing web. In case of DOM-based XSS, we have attack payload executed as a result of DOM updates. So this one is very difficult to protect against. In my own classification, it's better to focus on two orthogonal axes of XSS attacks, where data, one axis is where data is persisted, and the other one is where untrusted data is being used. So if there is no persistency, data persistency, no, so that's like stored reflected XSS. If the malicious code is being stored, it's like stored XSS. And we have server and client sites where XSS is actually being executed. For the first demo, I will ask you to go to https://demo.yonlabs.com. I will post links on my Twitter account named YonLabs. So please go there and observe some incoming messages to show URLs. The first one will be simple reflected XSS, and I would like you to observe how your browsers react. One more thing, don't include any confidential data during this demo, because it might happen that I will hijack your account or your web page. So be careful and don't put any real usernames, any real passwords. Just use some fake ones for the demo purposes. So let's go to the application and demo. I will post a link on Twitter. That's gonna be our first demo. We have a simple application with just like public comment section, and we have only one field, so that's suspicious, and most likely we have an XSS vulnerability here. So let me show you vector attack. The goal of this attack is just to display alert with XSS string, With most of injections attacks, we need to adjust some boilerplate to actually make the engine execute our code. So here we have like closing of a tag, and here we have like opening a new tag just to inject in the right place. Let me copy this one and let's switch to our vulnerable application. And what happens when I fill this comment, this edit field and filter? Yes, we have XSS alert popped up, but it depends. We can basically we can show this alert by filling out edit field, but also as this is like a get method and get requests, I can post entire real link with URL encoded attack. Okay, so you can try it yourself and see how your browsers will behave. And basically, the behavior of browsers differ. Sometimes, and for most browsers, an alert window will pop up. For others, like Safari, nothing happens. Why? Why so different reactions? Because some browsers use XSS auditor filter and some don't. So for example, Safari uses XSS auditor filter and by default it's active. On the other hand, Google Chrome deprecated XSS auditor in 2019. Firefox doesn't have any XSS auditor filter, so just interprets pages as they are. Why Google Chrome deprecated XSS auditor? Because XSS auditor filter produces a lot of false positives. So it may happen that a valid page is not properly displayed because some parts of it are sanitized and basically removed from being displayed. So because of a high rate of false positives and because it's relatively easy to bypass XSS auditor, that's why a lot of browsers retired the filters or didn't have any interest in implementing some. Let's take a look at Firefox browser and how it behaves in our case. Nothing happened. Let's take a look at JavaScript console, and you can see that XSS auditor refused to execute a script here. So that's why some browsers don't display this pop-up. Only a year ago, it was very simple to bypass XSS auditor used in Safari. It was enough to, instead of an alert, to put our alert code in a script and download the script. And that was it. That's not working anymore. So XSS auditor in Safari is being actively developed. However, there are other ways to bypass it. So basically, it's not recommended anymore. Instead of using XSS auditor, it's better to use content security policy. A couple of years ago, it was popular recommendation to use XSS protection header. Where once it was set to 1, it forced XSS protection and usage of auditor filter. So that's not a valid recommendation anymore. We will learn more about content security policy later on. And now, just for all of you to have more fun with demo, I will switch to disabling XSS protection. And in such a case, XSS alert is properly, from the hacker point of view, displayed with Safari as well. So now it's time for our second demo, and this is going to be phishing. Let me switch to actual attack vector. Again, I'm downloading phishing JavaScript from evil names from evil server, and basically executing the phishing script. What's going to happen? The phishing script basically overrides, in our case, login register page. And instead of, it uses the original code, but it replaces all action in forms with this with this action, which basically is sending. So instead of sending a form to a correct original server, the form will be sent to our server, which just stores down all information. So let's give it a try. And how does it look like? Let's switch to Firefox. And what happens when I insert my malicious JavaScript, malicious code into public comments and filter? Basically, we were redirected to this page. It looks like a valid login page. However, it's not. Once I put here username and some password, you can see that the response from the server is different, because this was the actual response from our hacker server. So basically, my username and password have been sent to hacker server. So that's a way of phishing when basically you replace the original web page with some malicious web page, usually redirecting users' actions to some hackers' servers and resources, just to, in this case, grab all usernames and passwords. So that's another demo. So in case if you would like to use it, I've prepared this malicious URL and you can try it yourself. I will post it again on my Twitter account. And give it a try. But be careful and don't put any real usernames or passwords. So that was a phishing attack with very, very high impact because usernames and passwords can be stolen. Now I will enable comment section, and I would ask you to log in, to register, create new account, and see what's gonna happen. I'm going to show you stored XSS this time. Okay, so switching to my server, I will enable comments. I didn't want you to mess up with my demos, so the comment section for adding new comments was disabled. Now, once you register and log in, you should see new comment section when you can basically add new comments. So I encourage you to add some comments, and I will add one myself. This one is for stored XSS. So basically, this is going to be very simple. That's another script. And this script just loads an image, and the URL of an image is basically sending your cookie to hacker server. So let's give it a try. jdconf is awesome. That's my main command, but I will add some extra information here. And here it is. It looks completely innocent. However, when we take a look at page source, we can see that the script is actually here. And every time you enter this page, in the background, the browser will send your cookie to my hacker server. So my kind request to you now, just go to this page and refresh it. And what I do is I will start observing logs. Or actually, that's another way which I prepared for you to see logs as well, is just go to the hacker server and access stolen path. So we see that a lot of information has been stolen. You can observe it by yourself. I will post this link as well. And we can grab some cookie and basically hijack a session. So what happens here? Now I will log in as a demo user. that's Firefox. I will use Cookie Manager add-on in Firefox. That's a very nice add-on to manage cookies. And simply, I can replace my original cookie with stolen one. I can save it and refresh page to see which user I'm impersonating now. So you see that was my original cookie from a different browser. Let's give it a try once again and try to catch another cookie. Let me refresh it. So we have some other cookie here. Maybe that's gonna be for different user. Again, I'm switching to Firefox and using Cookie Manager to change my cookie. And voila, that's artificial idiot. Yep, when you browse a web, you need to have some basic understanding of security. That's right. So basically here we've seen exploitation of weak session management. The original vulnerable application didn't use any cookie flags like HTTP only. HTTP only blocks access to cookies from JavaScript. So that's like basic security hygiene to be used by developers for the web applications. Another best practices for session management include random unpredictable sessions, some secure transport, storage, avoiding mixing HTTP and HTTPS. What happens if you use HTTP only and we can't steal a cookie? It looks like we can still use it because when we have an XSS in our application, we can basically force a victim to do an action as a prepared and forged by a hacker. And with XSS, any AntiCSRF protection doesn't work. In case of technical impact of XSS, you've seen session hijacking. We can scrape some sensitive information in very similar way. You've seen phishing. We can post data on someone's behalf. We can use malicious redirecting to send a user to a spoofed login page. We can use social engineering to download and open a file in that way, compromising the entire victim system. So it might be pretty dangerous. Fortunately, most modern frameworks provide very good defense against XSS. We have strong, we have input validation, we have contextual escaping, so that's very good. And that's not a simple thing, because if you take a look at those recommendations from OWASP, how to do proper contextual output encoding, it takes a lot of knowledge to do it properly. But is it enough? Unfortunately, no. Those XSS defenses are pretty difficult to configure. So from time to time, it still happens that modern frameworks have security vulnerabilities. So we need to be careful and include some extra anti-XSS rules, like implementing content security policy. Basically, with content security policy, we can block loading of resources from unknown sites. So we can limit, for example, scripts only to be downloaded from our original domain. So that's a very important anti-XSS rule. And the general advice is never trust user. So be wise and use your tools properly. And the answer to this is like continuous learning. As developers, we must keep educating ourselves. So thank you for your time, and you can find more resources on my GitHub, and you can reach me via email or Twitter.
I can't believe that you did live demos there and you got people to actually hit that URL and then you left it on there. Nothing goes right when you actually ask people to hack you live on air though, but it worked well. And I'm going to go rewatch those demos there because I've got some websites that I've hosted on Azure, but I didn't do all of those things that you mentioned there. And I feel a bit embarrassed then to go back there about that. And I've used CodeQL to go and scan for for XSS, and it's alerted me to a lot of those issues with CodeQL. That's GitHub Advanced Security. And I've also used WebGoat to actually go in and try and learn that though. But what you showed me today goes a little bit more deeper into how to prevent, how to and analyze, and then how to actually make sure that you make your users aware of the cross-site scripting.